Hello and welcome back to Geek Fun Facts Online, the channel where we dive deep into the amazing world of science and technology. Today, we're talking about something that affects almost everyone who uses a computer, a phone, or even just the internet, which is pretty much everyone, right? We're going to explore a hidden bottleneck that slows down our digital world and a super clever new technique, codenamed Skia, that's helping to speed things up. Stick around, because this is some seriously cool tech. So picture this. Your computer's processor, its brain, is trying to juggle a gazillion tasks at once, especially in those giant data centers that power our favorite apps and websites. These processors are under immense pressure. One of the biggest headaches they face is figuring out what to do next. They try to predict the upcoming instructions to keep things running smoothly, but often they get it wrong or just can't prepare fast enough. This creates a sort of digital traffic jam, slowing down everything from how quickly your search results pop up to the overall efficiency of huge computing systems. A key part of this prediction problem involves something called the branch target buffer, or BTB. Think of it as a small, super fast cheat sheet for the processor, telling it where to jump next in the code. But when the answer isn't on the cheat sheet, that's a BTB miss. The processor has to pause, and things slow down. With today's complex apps, these misses happen a lot. But fear not, because brilliant minds are on the case. Researchers at Texas A&M University, along with experts from Intel, AheadComputing, and Princeton, have developed a novel technique to tackle this. They call it Skia, which is a Greek word for shadow, and it's all about enhancing something called CPU branch prediction. Branch prediction is basically the processor trying to guess the outcome of an if statement in code. Like, if this happens, do that. Otherwise, do something else. Getting these guesses right is crucial for keeping the processor fed with instructions and running at full tilt, which also saves power. So, what's Skia's secret sauce? It focuses on what they call shadow branches. Imagine the processor has already fetched a bunch of instructions, like grabbing a whole paragraph from a book. Some of these instructions are branches, decision points, but they haven't been officially identified and logged in that BTB cheat sheet yet, maybe because they're a bit further down in the paragraph the processor is currently reading. These are the shadow branches. Skia discovered that a whopping 75% of those troublesome BTB misses are actually due to these shadow branches hiding in plain sight. Skia cleverly identifies and decodes these shadow branches from the unused parts of the instruction data that's already been fetched. Then, it stores them in a special, dedicated memory called the shadow branch buffer, or SBB. The really smart part? The processor checks this SBB at the same time it checks the main BTB. So even if the main cheat sheet, BTB, has a miss, the processor can look at the SBB and keep on speculating and prefetching instructions, avoiding those stalls. This approach is pretty ingenious for a few reasons. Firstly, it uses information that's already been pulled into the processor's instruction cache, so no extra, costly trips to fetch more data are needed. Secondly, it doesn't get in the way of the processor's main tasks. It doesn't pollute the critical path, as engineers say. By essentially making these hidden shadow branches visible and usable, Skia supercharges the processor's ability to see what's coming down the line. And the results? They're impressive. With a relatively small hardware footprint, just about 12 kilobytes of storage, Skia has shown an average speedup of around 5.7%. Now, that might not sound like a huge number, but in the world of processor performance, it's significant. To put it in perspective, that's about 2% better than if you just took that same 12 kilobytes and added it to make the existing BTB bigger. Skia is more efficient because many of the branches it finds and stores in its shadow branch buffer are different from what a bigger BTB would hold. This means more unique, helpful predictions. It's particularly good at finding branches that sit at the very end of a line of code, which can be tricky customers. The development of Skia is a really valuable step forward for how we design processors. By illuminating and using these shadow branches, it opens up a path to data centers that run more efficiently, give us quicker performance on our devices, and even consume less power. It's tackling a key problem in modern computing, helping to create hardware that's better equipped for the massive, complex applications we rely on every day. Now, Skia is a fantastic innovation, but it's not the only cool thing happening in the world of branch prediction. Researchers are constantly exploring new ways to make processors smarter. For instance, there's a huge buzz around using deep learning and machine learning. Imagine AI models, like the ones that can recognize images or understand language, being used to predict where code will go next. Scientists are looking at things like convolutional neural networks and even compact versions of transformer models, like TinyBERT, to spot complex patterns in code that older algorithms might miss. Some of these AI predictors learn from tons of data beforehand, while others are hybrids, mixing old and new techniques. Beyond AI, there are other clever ideas. Some are developing advanced predictor architectures, like a last-level branch predictor. Think of this as a bigger, backup cheat sheet that uses more context from the program to help the main predictor. Then there are profile-guided optimizations, where compilers, the tools that turn human-written code into machine instructions, actually rearrange the code to make it easier for the branch predictor to guess correctly. There's also ahead prediction, which tries to look even further into the future of the instruction stream, though a key challenge here is managing the energy it takes to do that. And finally, folks are still working on optimizing the branch target buffer itself, looking at multi-level BTB designs to get the best balance of speed, power, and accuracy. So as you can see, while the Skia technique is a really specific and promising way to improve how our computer brains work by using those shadow branches, it's all part of a much bigger picture. The goal is always to enhance computing performance through smarter, more efficient instruction handling. As the software we use gets more and more complex, these kinds of advancements in CPU architecture are absolutely critical to keep everything running smoothly and quickly. And that's our deep dive into the shadows of your CPU for today. Pretty fascinating stuff, right? It just goes to show that even in the components we use every day, there's always room for incredible innovation. Thanks for tuning into Fun Facts Online. Don't forget to like, subscribe, and hit that notification bell so you don't miss our next exploration into the wonders of technology. Until next time, stay curious.